Hello and welcome back. I'm going to start up here on part 2 of our 6.10 stuff. We are doing this kind of mess. We just left off with example 6. What we did is we listed out all the possibilities. We plugged in some of them until we got one of them to work. We got a 0 down here. Factored out the rest of that stuff. And then from there, this one we couldn't factor, so we had to use our ugly formula to figure out our 2i answers, the 1 plus or minus 2i. So this gave us our 3 different answer choices here. We're going to use this same process and then some for these questions here. And look at all this information that we can now tell you, or you can tell me, I guess, about a different polynomial. What's our degree here? Well, that's our biggest power, which is 3. Possible roots. Well, what's going on here? We got plus or minus 1, plus or minus 3, 5, and 15. And since the front is just a 1, that's all over plus or minus 1, so it doesn't even matter. Alright, so we got 1, 3, 5, and 15 is all of our possibilities. Actual roots, that's the work we're going to have to do. Alright, hey, remember this stuff. End behavior. What's going on with our graph as it goes to positive infinity? That's the right side. Well, the right side's told me by the front here, which is going to be a negative infinity. Now the left side, remember, is always going to be either the same or opposite depending on the power. The power is odd, so the left side will be opposite, and that means it's going to then go to positive infinity, which is much better. Everybody likes positive infinity better than negative infinity, right? I don't know. So, we're close. We've got a lot of information, but now we need to plug some stuff in. I went ahead and plugged in 1, and 1 did not work, so I'm going to try something else. I'm going to try a negative 5 here, just because I feel like a lot of positive things here. We need something negative to kind of move it back in the other direction. Minus 3, 13, and 15. Alright, so we're going to plug that in. We got negative 1 times negative 5 is going to be positive 5. Leaves me with 2, negative 10, 3, and negative 15. Gives me 0. Is 0 what I wanted? Yes, it is. So that means negative 5 is one of our actual roots. So now what we know is going on is we've got x plus 5 times negative x squared plus 2x plus 3. So now we can think about, do I want to plug this into our negative b plus or minus squared b squared minus 4ac all over 2a, or do we want to try and factor it? Anything multiplied to 3, subtract to make it 2? Yeah, 3 and 1, right? The only thing is we've got this negative sign out front here. So I'm going to factor out that negative, just stick it out in the front, and that means I'm going to change the sign of all these things. So it'll be x squared minus 2x minus 3. So we got x here and x here. Minus 3 times positive 1 should get this to work. Minus 3 and plus 1. And x plus 5 out here. And hey, look at that. Now we've factored the whole thing. Negative 3 times positive 1 makes that. Negative 3 times, or plus 1 makes that. So we're good. So I got negative 5, positive 3 for my middle term, and negative 1 for my last. And those are our 3 actual roots. So now what we can do with all this wonderful information is we can go ahead and graph it. And let's use happy faces. So all of our roots, those are our zeros. Those are where our things are going to go through. So we've got one at positive 3, we've got one at negative 1, and we have one at negative 5. So we're going to put those on here. We talked about how the right side was starting out at negative infinity, right? So that means this side is going down. Our other side was going to be opposite, so it's going to end going up here. Now, another thing we can think about is our y-intercept is going to be 15. So we know that it's going to go up pretty high. This only goes to 5, so 15 is way up too high. So I'm not going to worry about it, but it's just something else we could think about. And now we get to draw a really ugly graph. Oh, I'm sorry about that. I need to undo that, but I need my eraser for that purpose. Let's pretend that didn't happen. Hopefully yours is working out a whole lot better. Oh, goodness. Ew. This is the only thing that's not easier to do on this little strange little mouse patty thing. So there's my disgustingly ugly graph of our polynomial that we just factored all on our own. Look at the amazing things we can do with math. Alright, so fear not. We won't look at this and be scared. We say, we know all kinds of information about you, Mr. X cubed. Your degree is 3. Your possible roots, well, it's going to be plus or minus 1 and plus or minus 3 over plus or minus 1 and plus or minus 3. So what is that going to give us? Well, the 1 or the 3. So that takes care of this guy. 1 over 3 is going to be new, 1/3. And 3 over 3 is just 1, so there is no more. So 1, 3, or 1/3 are our possible roots. The right side, our positive infinity. Well, since this is positive, that means it's going to positive infinity. Left side, since the power is odd, is going to go to the opposite, which is negative. Man, look at the information that we hold about you, Mr. Polynomial. So, what number do we want to plug in here? I don't know. We've been trying things with positive 1 all the time, so let's try 1. We got 3, 7, -7, and -3. 1 times 3 is 3, makes 10. 10, oh, look at that. Makes a positive 3 and 0. Man, it's like I knew what I was doing. So, 1 is one of our actual roots. That means x minus 1. This becomes 3x squared plus 10x plus 3. Alright, awesome. So what do we want to do from here? Do we want to go ahead and try and factor that? And nobody wants to do AC method with that 3 in the front. So what we're going to do, I'm just going to use the formula, the negative b plus or minus, blah, blah, blah. A, B, and C right here for us, because we know that's always going to work. So I get -10 plus or minus square root of b squared is 10 squared minus 4 times 3 and 3 all over 2 times 3. Well, this looks disgusting. What's that, 100? What's 4 times 3 times 3? 3 times 3 is 9 times 4. Make minus, what, 36. So we're going to get a -10 plus or minus 100 minus 36 is 64. Oh, that's nice. I know the square root of that. And 2 times 3 is 6. Alright, we're getting close here. Square root of 64 is 8 over 6. So, we got our 2 different problems to do. We got to do the 10 plus the 8 and 10 minus the 8, divide both of them by 6, and see where we are. -10 plus 8 over 6 is going to be, what's that, -2 over 6, which is -1/3. Hey, look at that. 1/3 was a possibility. So if we would have plugged -1/3 in here instead of 1, it would have worked. It would have been ugly, but it would have worked. Alright, -10 minus 8 this time over 6 is going to be -18 over 6, which is -3. And hey, again, another one of our possibilities. So that's cool. We got a 1, -1/3, and -3 as our 3 actual roots. So we're going to go over here and we're going to graph those things, because graphing is what we do. Let's go with clown points this time. So I got my -3 right here, I got my 1 right here, and my -1/3. And we just kind of stick that in here between the 1 and the 0 and hope for the best. Now, what we had here is a -3 for our b-intercept. So I'm going to try and make that work for our graph. That means it goes through this point down here too. This is completely optional, but I know my people expect me to be thorough, so I'm going to try and be thorough. We're going to go through that point down there. Alright, we said it started out positive and it ends up negative, so it's going to be kind of going swooping on through here. So we're going to go on down. Oh, that started out so bad. Swoop down, we're going to come back up through here and back on down. Oh man, this is gross. Again, I'm apologizing for your being forced to witness what is occurring right now. Nobody wanted this to end this way, but look at that. There we go. If only I had a smooth it out tool for graphs. That would be fun. So that's kind of what our graph looks like. We even got this bonus y-intercept down here that we know it goes through. So awesome stuff. I hope your graph looks prettier. And I think we got time to do just one more. So I know you're not satisfied. You're like, man, what happens if I have a fourth degree? Oh man, that means there's 4 roots. There's 4 times the fun now. So possible roots. Plus or minus 1, plus or minus 2, 4, and 8. Since they're all over just the 1 on the front, we don't have to worry about anything else. Positive means my right side is going to positive infinity. Even power means my left side is going to the same place. So we got one of those W graph kind of situations going on, and we want to find all these points where our W graph is going to go through our x-axis. Or maybe it doesn't that many times, I don't know. So let's give it a try. I'm going to plug my 1 in here and see what happens. I got a 1, a 2, a -9, a -2, and an 8. Man, this is so much work. I can't believe we would ask a high school kid to do all this adding and subtracting right here. You're probably upset with me, but that's the way it goes. That's the way it goes. 1 times -6 here. Oh, 6, 7, 8. -8. -8 gives me 0. Happy, happy, happy. So my 1 worked. That means I've got x minus 1 here. And the rest of this stuff is going to be now x cubed, just looking at our numbers down here, plus 3x squared minus 6x minus 8. Now wait a second. Is this something I can factor? No. Can I plug this into my negative b plus or minus squared b squared minus 4ac all over 2a? No. So what I need to do is I need to do the exact same thing I was just doing before. I need to find out with some synthetic substitution with this new polynomial what's going to work. So 1 worked already. I'm going to try 2. Now again, I'm not pulling the same numbers I had here. I'm pulling my numbers from my new polynomial, which is a 1, a 3, a minus 6, and a minus 8. So let's work through this one. 2 gives me 5, gives me 10 minus, oh my goodness, 2 times -4. Is that right? Is that right? Oh, this is positive 4. Why am I writing -4? -6 and 10 make positive 4. 2 times 4 makes 8, makes 0. And we are happy again. So, look at that. We've got x minus 1 from before. We got x minus 2 now. And then we've got x squared plus 5x plus 4. And hey, can we factor this? What multiplies with 4 and adds up to 5? 4 and 1. So that's really an x plus 4 and an x plus 1. With our 2 original, x minus 1 and x minus 2 there. So look at that. We just factored a 4th degree polynomial like it was nothing. So my actual roots, again, we're taking the opposites of all these things. That's a positive 1, a positive 2, -4, and a -1. Look at this wonderfulness. All right. We've got our y-intercepted 8. We've got our 4 roots. We are ready to go. 8's too high. It's way up there. That's okay. So we'll put my -4 here, -1, positive 1, and positive 2. Both of our end behaviors were up, so it's going to swoop through like this. And I know aesthetically this isn't a good looking one either, but I don't know, you got to deal with it. Hey, and look at that. All the amazingness we just did. Let's start getting ready for you guys' test, and hopefully, great things are going to happen in your future.